probably was the material, got grabbed by the saw, got pulled into the saw, which is a very common occurrence with chop saws. When you're cutting wood, it doesn't happen as much, but when you're cutting aluminum and extrusions, because of the shapes and the nature of them, that happens. So anyway, so the blade that was in there, grabbed the material, bent the blade, took a couple teeth off, no big deal. Fortunately, people weren't hurt and all was good. So we've got a new blade here. Couple things about the blades, they'll come, you don't want to use a dull blade, obviously, with any tool. The sharper it is, the better it cuts, everything. A sharp blade through the aluminum will cut clean with no burrs, and you have to do very little filing and things afterwards. So they all come with protective coating on them. A saw, there's a certain rotation and a certain way that the blade needs to go on there. It will be marked, the rotation. Generally, your blade will be marked with rotation as well. With arrows, this blade is not marked with rotation. So the way that the blade cuts with the rotation this way is the teeth are going to hook into the material. So just knowing that and knowing the way the blade works is this is not really a consumer blade that you would buy in Lowe's or anything like that that'll tell you how to install it. So we just know how to install it on this one here.
So the teeth always cut down into the material.
Yeah. If it was on there the opposite way, it would just be running on the back of the teeth, and it would just make a big loud noise, and probably jump away from you and things like that. So anyway, so we'll put the blade on there.
Would it be helpful for them to come around the other side or not?
That would be fine.
Okay, guys, why don't you go to the other side and see what's happening on the other side? You gotta take a call.
So the first thing is making sure we're unplugged, which obviously we are.
But it's only obvious because you did it, right?
Yeah.
Okay.
And we're gonna put this is what secures the blade to the saw, and there's also a saw stop on here which will hold the motor, and I'll show you in a second here. So right now the blade will turn freely. Normally we'll take a piece of wood or something and drive the blade into it is one way to do it, or so it doesn't spin on you when you're tightening it on, or you can, that just fell in there, there's a detent that stops the motor from turning, and we can tighten up the blade to make sure it's secure, and you'll just tighten it as tight as you can get it. So now the blade will spin freely. This is the stop bit. So when you go to take the blade off, you'll want to find that detent to unscrew the blade.
So you're holding something on the other side to keep that?
Right here.
All right. So I dare 3 of you to go up there and find the detent that he just did. And I want at least a couple of girls get in there too. So much for chivalry. Ladies first. Spin it a little bit.
What that does is that stops the motor, so you can tighten up the shaft to make sure that the blade is properly tightened and everything like that.
All right, so I think they're unimpressed with my insistence that they do. I can feel Cassidy's eyes rolling and be like, "Oh, please! It's a button and I can push it. Just back off, Hampton."
One of the things that, because the blade was already taken off of the saw, there was a little screw here that allows the cover to go on here. I have to put this back on there.
You mean the safety guard cover? Is that what you're talking about?
Right, the safety guard. And what that gave me was the access to the.
So you took it off so that you didn't have to fight the cover while you were moving the blade.
Yeah, so you can get to the bolt that secures the blade. So now we'll cover that back up.
Now we really shouldn't have much reason to go taking the blade off unless there's a problem with the blade.
Normally, I mean, you'll get, in our shop, we cut aluminum. Our saws run all day long. I mean, we'll change a blade about once every, maybe 3 weeks or so. So, I mean, you have a very good life expectancy with the blade if it's used properly and taken care of. So now that the guard is back in place, the guard works securely. you pull it down, it'll expose the blade and go back. So basically at this point, the saw is ready for reuse, which at one point we would turn it, plug it in, try the saw, make sure everything works and looks good, and then, you know, be ready to cut at that point. Couple of the things with cutting extrusions, when you cut wood, wood is much softer. Just with a sharp saw blade, just goes in and cuts. The nature of a chop saw, where the blade hits the extrusion or whatever varies by whatever thickness material you have. So like this thickness material here, you can see it's going to bite in here at the back of the extrusion, or the piece of ply or a 2x4, and just want to push it back against the stop. If you have, you know, like up here, you're hitting at a different point. So no matter how you're cutting things, you hit at a different point on the size, the dimension of the material. With wood, it's not a big deal. With aluminum, when you're cutting aluminum extrusions and things like that, depending on where you're hitting, depends on how much it'll want to either push against there or flip it over sometimes. And if the material is not secured in some way, that's when it'll get caught in the blade, and then want to, you know, and the blade spinning at 2,500 RPMs or whatever it is spinning very fast. It'll all happen very fast, and take it in there, and, you know, sometimes it's not a big deal, other times it is. So, like this extrusion here, a lot of what we see is people cutting like that extrusion, like they'll want to lay that extrusion down in an angle is the perfect example, or unequal leg trims with aluminum.
And that's bad.
This is very bad, because
Okay.
what happens is where that blade wants to hit, where that blade wants to hit right there, if you envision this blade spinning this way, it just wants to grab that piece of metal and roll it over. So although the blade is very sharp, and you envision in your head, well, it should just go and cut, it's actually wanting to just roll that piece of metal, which, and then what happens is if it gets a little bit of chatter, and then it's going to pick that up, and that's what's going to roll. That's where you're going to start shooting things out of the saw, which you don't want to do. So in a situation like this, you know, we want the metal against the stop, you know, against the back and against here any way we can. Same things if tubes are, you know, wider, you know, if you can lay them down like this and cut where it comes back into this corner better. So you just kind of look at what you're cutting. So then the other issue is no matter what you're cutting on the saw, it should be secured down with a stop in some sort of fashion. Now we grabbed this one and brought this here, so you can secure the metal to the saw, because the other thing that the saw, as you're cutting it, it may want to not only, it may want to cut through nicely, but sometimes it'll start drifting left and right too, because the aluminum, it wants to pull it around. So as you're cutting it, it'll want to change things. So no matter what you're cutting here, you want it secured down in some way, shape, or form. You can use a squeeze clamp, squeeze it, you know, with you know, similar to this type of clamp, where you could clamp it to the saw itself. But everything that you're cutting on a portable saw like this should be secured in some way, shape, or form. And you know, it's quality of cut, it's safety, it's everything, it's all that involved there. So for multiple reasons. The other thing about cutting aluminum is the thicker, the more you cut aluminum and the thicker you cut aluminum, and I brought some pieces, we can cut some thicker stuff here in this as well, is aluminum needs lubrication. You don't want to cut it dry. So when you're cutting wood, you just cut wood all day long. It's soft, you cut it, life is good. When you're cutting aluminum, you need some sort of lubricant on the blade, because what happens is as it's digging through the blade, you know, or digging through the material each time, the blade starts getting sticky, and aluminum will start building up into teeth. Now I've worked around this all my life. I listen for the saw, like I'll be in my office and I can hear the saw change pitch in the shop and say, hey, you got something going on in the blade. There's either a piece of material gets stuck in the blade, but as aluminum, if you continually cut dry, like you can cut 10 or 12 times right now, it'll be great. Life will be good, no problem. And then all of a sudden it'll start feeling a little bit different. It also extends the life of the blade, and it gives you a better cut. You'll notice you'll have a little burr on the back. You spray it with the lubricant, and then there's no burrs. It's a nice clean cut. So, with regards to basically clamp your material, lubricate your blade, and but make sure the material is secure. Another thing that we do, because we cut a lot of sheet goods and thin material, such as stuff like this. What I do with stuff like that, if that were a longer piece of material, we use a lot of plywood and or 2x4s and stuff with it. So like if you were cutting something like this and it was longer, because as the blade wants to, now see like this would be bad to cut on here. You don't want to cut. Now you could cut this on here, and I'm not, there's different ways to do it.
Let's just go with it, it's bad to cut.
Right, if you could do it by raising it up into the stop. There's different ways of doing things. But if you get a lightweight material that you look at it and think, that might chatter around a little bit, if this stop work, is you can put a piece of plywood or something right next to your cut and clamp that down with it. That way your piece of material will not move, it won't shatter. And
so it's like an indirect clamp.
Right, and so the other thing about, like I said, when I keep saying chatter, you'll start feeling an aluminum if it starts grabbing, back off, and you can always reset your cut and go, So, but especially.
Okay, so if you feel it start chattering, you take the saw back out of the cut and stop everything. And
other thing too, one of the things I did discuss, when you're cutting any type of material on a chop saw, you get your mark laid out where you want to. We put our mark on our piece of material. We can get this lined up. We don't put our hand on the trigger. We get it lined up where we need it. We clamp our material, then we come back. We then start the saw. The saw needs to be spinning before you go near your material. So if you put it on there and try to start the saw with the teeth on the material, it's just going to want to rip through it's just going to be bad. So blade needs to be spinning, and there. The other thing is, like I said, with clamping, you got to make sure it's back against your stop. If it's away from the stop, it'll immediately is going to slam back there, and the saw is going to want to jerk, and yes.
2 questions.
Yes.
First of all, so about the lubricant, how do you put it on?
I'm going to show you that in a second.
Okay.
Yep.
And then the second thing is, why does that say aluminum cutting only if we're discussing the sign right there? It says aluminum cutting only, and we're discussing cutting wood. Because now I feel like I don't know what I'm doing.
Okay. A non-ferrous blade there's 2 types of metals. There's non-ferrous, which is non-iron. Ferrous is iron, which means steel. Okay. Steel, like black pipe and the things that the chassis are made of, that's iron bearing, which is ferrous metal, has steel in it. These types of blades are not meant to cut steel. So in non-ferrous, metals are aluminum, brass, copper, that they're not iron bearing metals. So
magnet won't stick to them.
Right, the magnet won't stick to them, and they're soft. They can be cut with a non-ferrous blade. The non-ferrous blade though can also cut wood, because wood is soft. So if you can cut, so basically, don't cut,
okay.
Right. So basically with an aluminum cutting or a non-ferrous blade, we can cut aluminum, brass, copper, and wood. So you're good with that. We switch back and forth all the time, it's no problem. But you do not want to cut anything steel. If a magnet sticks to it, you don't want to cut wood. Yes, sir.
Well, I was just wondering about the fence behind it, or the backstop. It looks like there's a gap between the wood and that metal. Is that out of alignment, or is that the way it's supposed to be?
I was going to look at that.
Okay.
And I'm going to be honest with you. This is a die cast, a cast piece here, and on occasion they will. I don't know if it's the rip on the wood, which it could be. I was just, as I was looking at that, I don't think it.
Because It should be all in alignment.
It
shouldn't
should. That's what I was going to talk about with cutting 2x4s. Now that it's possible, and I'll loosen that up and see if that can come out. But if it's truth be told, it's possible that when it got
manufacturing defect.
well, when it
when
hit the other day,
when we hit it. Yes.
did it? Usually an extrusion or a cast piece doesn't do that, but we've had them happen on our saws where it's got jammed so hard that it's forced the thing back. The other thing about cutting wood, now extrusions, when you cut them, they're mostly hollow. So you're just cutting through a layer at a time. When you cut through a solid piece of wood, say like we were cutting 2x4s the other day, 2x6s, those have bows in them sometimes. And what he's talking about here with this little space back here. Mostly cutting stuff like this in extrusions, that little space, if there's a little bit of a space there, not a problem. If you're cutting a 2x6 and it's bowed out, or 2x4, you'll feel it'll start grabbing on the blade. And what's happening is if you've got a space behind there and you're cutting, as the wood starts relaxing because you're cutting through it, it'll start pushing back towards the fence and it'll be clamping down on the blade. And it'll then it'll bite, because then the force of what you're cutting is like a vise, like a clamp that just grabbed the blade, and it'll start wanting to kick back. So you gotta, sometimes if you feel the saw back up, come down into it again. If it bites again, back up and come down, and you'll actually cut clearance paths through it till it just goes through and then naturally falls through. So we'll take a look at this. Cutting the extrusions and stuff like this, I don't think it's a real big deal. But I'll see if there is adjustment, things here, if we can adjust that a little bit and get that out of there. But that will happen because the force is so great. When this motor grabs and holds a piece of metal, and obviously you saw them, it can do some damage.
Okay.
And I mean, I had one time where I had all 4 of my fingers smashed in black because I did an extrusion this way, and I was just holding it down on the saw. And it went, and I mean, it was months of, you know, and so it grabs it, you know, so you just gotta be careful, and they are safe if used properly and everything like that. So lubricant, when you plug the saw in, you know, use it, you get the blade spinning, and you just give it a shot on one side, give it a shot on the other side where you can see the blade. It doesn't have to be on the teeth, it can be right in there, because the force of the blade spinning just shoots it out to the edge of the blade.
So we do not move the guard,
You don't
blade
need to move
guard.
the guard. You just hold it right there, turn it on, give it a shot, and then cut down into the material. You don't need to spray it on the material or anything like that. We will, like, if we're cutting thick, some, you know, production saws and big commercial saws have a mister on them. They've got a mister, so when the saw blade starts moving, it shoots a fine mist from an automatic, you know, a tank.
We have misters too, but they're just teenagers.
Right.
Yeah.
But as you cut thicker metal, you know, like this, we would shoot partially through. You know, we would, you know, we'd have this and then grab and give it a shot in between to lubricate it all the way through the cut. You know, but most of the stuff you'll be cutting and things like that, just make sure it's got a, you know, a quick shot on both sides of the blade before you go and
Okay.
So, so that's pretty much that. And then, go ahead.
Okay, so to me personally, I don't think that looks safe unless it's like a flat piece of metal.
What's that?
This.
Oh, it'll work. Because what you're trying to do here, like this, you know, this. If you take this, you're gonna push the metal back towards the saw, and then this will clamp it down, so it doesn't move left and right and or chatter.
We'll go up and feel it, Cassidy.
Yeah.
Go feel it.
Okay.
What is it that you're?
I don't know, it's just like that.
Yeah, but that's okay because it's trying to, you know, I can't move it left or right. You know, it's good, it's secure, and as long as it's pushing back,
Because the blade's not gonna.
the blade is going to force it against this stop here. It's going to force it against there.
Okay.
So.
Well, I trust you.
Yep.
We're good.
No, it's okay. And like I said, if you have, the other thing, like I said, we have, you know, and that's why I brought a couple different pieces of plywood and stuff. Like I said, you can lay that on there, clamp it off, you know, if you're concerned, you know, you can put a piece like this, clamp it on there. As long as the material is secure, you're going to be okay. The other thing, this is an adjustable miter saw, and when you miter with a saw like this, and you can cut all the angles and everything like that, they work great, but it's back to making sure the material is secure, because as you cut a miter now, instead of like here, and a lot of it's just feel and use. Here, we're pushing straight in, both sides of the blade, life is good. When we go to like a 45-degree miter now we're cutting at an angle, we're pushing back this way now, so it actually wants to suck this piece of material, the natural force of the blade going this way and you cutting an angle wants to start pulling your material into the blade. So that's why it's secure, to make sure, it's so important to make sure you're clamped down.
Okay.
Now, we should be able to, we actually tried to buy this clamp today at Farm and Fleet, we thought, and they didn't have one, and fortunately we had one from one of our saws in the shop, so I grabbed that one. So if we can find another one, I would recommend having it on both sides.
Okay.
You can't go wrong, you know what I mean? The more secure everything is,
Okay.
but for the time being and things like that, one is good, and or like I said, you could like here.
We can use our wood clamps for that
We
too.
can throw this on there, put a clamp on there, and as long as our material is secure, we're gonna be safe.
And we should probably not be cutting any angles this season. Maybe over the summer we'll work on that sort of thing.
Oh, miters and stuff like that, yeah.
Yeah, I would think we should be limiting ourselves to straight cuts.
Straight cuts and things like that.
That'd be
yeah.
my guess.
But like I said, as long as the material is secure in the saw, but like I said, you gotta look at the shape, and like I said, don't cut anything with a point. If it's not secure against this, the saw is going to push it against that stop.
So there should be a flat surface against the back
Yep.
fence and a flat surface against the ground or
Yep.
the table.
Right.
Is that
And then-
correct?
Yep. In like these extrusions here, we're gonna cut a little bit in a little while here for Mark. You can,
Can we do some test cuts
absolutely.
or have
Oh,
these
for
kids
sure,
do some
yeah,
test cuts?
Yeah.
I
But
want to ask a review question. I'm sure you've addressed this, Mike, but I wasn't in here, so I want my kids to tell me. How are you, once you put on the lubricant, what kind of approach do you have to actually cut it? What instructions did he give you from there?
We didn't-
Like start spinning before you.
Let it spin before
Yeah, we're gonna
you-
get there.
Oh,
Right.
okay.
So we've lubed it. We're all lined up because we already lined everything up. We're good. We're lubricated. We can either then go right into our cut, or we can stop and go in whatever you're comfortable with. But so at that point, when you come into the metal, you're gonna have the trigger pulled, all the way. You're gonna go in, and you should be, standing straight behind it now. Here, you can have two hands on the saw, whatever you're comfortable with, as far as bringing it down.
Except
But
we're not pushing hard
You're
on
not,
it.
that's what I'm saying, you're gonna be full pulled back on the trigger, and when you come in there, just let the saw do the work. You don't want the pitch shouldn't change a lot. If you hear the pitch of the motor change like it's straining or anything like that, you're pushing it too fast and pushing it too hard. The saw will do the work. Once you hear it, kind of whine a little bit, once it hits the metal, then just go through it the same. But it's a nice, slow, steady, drop it through, make sure you bottom out, that the saw bottoms out, and then pull it back up. And the reason you want it to bottom out is to make sure that it fully cut this back corner. There's not a real lot of bypass on the blade, so if you're up a little bit, like right there, I'm leaving material uncut. So you gotta drop the saw all the way down, and then you can just let off the trigger and bring it back up. So you can, I think the safest thing for you guys to do would be to make the cut, leave the saw fully down, let off the trigger, and then bring the saw back up at that point.
Okay.
Would be probably the safest practice for that, So full rotation, bring it slowly through the metal, bottom out, and then let off the trigger, and then pull the saw back out of the material. So hands shouldn't be on the trigger no matter what you're doing. Anything that you're doing to the saw, emptying the bag, there's a bag back here. Any of that maintenance, first thing you need to do is make sure the saw's unplugged. Yes, sir, Michael?
Where could you brace your hand? You're cutting a steak, brace your hand.
You could put it here, you could put it down there if you wanted to use,
Just like that.
right, depends on how you want to do it. Just nowhere near the saw or the material, And like I said, if you wanted to do 2 hands on there, you can do 2 hands if you're more comfortable with that. If you're more comfortable with one over here is fine. Just keep it out of the, you know, the path of anything that, you know, could happen. So,
Okay.
but like I said, the securing of the material with this type of thing is one of the biggest factors. So, and they will, and as you can see now, same thing with that blade that it's over there. Once that happens, do not use the blade. They can fix a blade like that. They can re-weld carbides on there, the tips, the little, basically what the saw blade here, this is like a tempered mild steel, and then there's a carbide tip on there, which is carborundum. It's a very hard metal, and the reason they use that is so they can sharpen it. It's very, very hard, it lasts very long, and they can sharpen it, and it can resharpen. But they're actually brazed on there, they're welded, and like when you hit a piece of material, they'll pop out. They can re-weld them on there, resharpen. That blade in particular, if you look at it, the tooth is bent. So what'll happen if you were to try to cut another piece of metal on there, the second that blade hits the metal on the rotation that piece that's sticking out hits the piece of metal, it's gonna jump back at you because it's not, the saw has got to cut in a very perfect straight line. So if anything like that happens, just put a new blade or a resharpened blade or your old blade on there or whatever you have. But
Okay.
the other thing about, you know, just talking about the blades, this is a 100 tooth blade. That was a 96 tooth blade. In that range for this size is a nice amount of teeth. The closer the teeth or the more teeth that you have, the smoother the cut. Yeah, the smoother the cut that you have. So, anyways, so do we want to make some cuts?
Yes.
I would, one thing about you
Yes.
guys using the circular handsaw, there's a spot when you're cutting wood, you have to muscle that. You never have to use
Right.
muscle on this one, never.
Yeah.
That's the enemy for this machine.
In
Yep,
fact-
we let the saw do the work here.
Most people should not probably be using 2 hands to push the blade down. I mean, maybe, but